Olá pessoal, sejam todos bem-vindos. Hoje é mais uma transmissão em nosso canal, o IPTV. Hoje, transmissão histórica aqui no nosso canal, 22 de fevereiro de 2024, 19 horas 17 minutos, pelo horário de Brasília. Então, iniciando a nossa cobertura especial aí para o pouso do Odisseus, nova cena do Instituto Machine, lá no Polo Sul da Lua, né? Que foi lançado então aí pela SpaceX, né? Esses dias aí, então foi no dia, deixa eu só relembrar então para vocês, né? Foi no dia 15 de fevereiro, né? Que tivemos então o lançamento com a SpaceX, né? Do módulo de pouso lunar do Odisseus, né? O nova C, né? E hoje então horário então para o previsto, né? Para o pouso na superfície na Lua, né? No Polo Sul, né? Tá previsto então aí para as 20 horas e 24 minutos pelo horário de Brasília. Então vamos acompanhar, né? Todos esses detalhes aí então aí do momento então deste pouso, né? Eu achei que não conseguiria aí transmitir, né? Por conta que eu falei já com vocês, né? Aí que durante os dias de semana, segunda a sexta, aí entre as 2 e as 19 horas, né? Aí eu não ia conseguir transmitir para vocês as missões. Mas como então mudou os horários, né? Aí do pouso, né? Aí então hoje então consegui aí finalmente então trazer para vocês todos os detalhes então aí do pouso então na Lua, faltando aí, então 1 hora e 14 minutos para o pouso lunar. Aí então o horário previsto aí para o IM-1, né? E vamos acompanhar então juntos aqui esta cobertura especial, né? Então siga o nosso canal no YouTube, aqui no IPTV, e também aí se inscreva e deixe o like na transmissão. Vou fazer um pequeno rápido intervalo, aí eu já volto com vocês aí. Não se esqueça, né, que estaremos juntos aqui nesta cobertura especial aí do pouso na Lua, né? Ou melhor, na tentativa, né? Espero que seja conseguida então aí com sucesso, né? Esperamos aí, torceremos que ocorra tudo bem, né? E vamos acompanhar todos os detalhes então ao vivo. Volto já já.
NASA is really good at doing robotic space science missions, whether that's the James Webb Space Telescope or it's the Mars rovers. But when we knew about 5 or 6 years ago that we would start going to the moon to do science and exploration investigations, we knew we'd be going back every year, so we turned to industry to see if they could actually take us to the moon instead of us having to do it ourselves. And that's how we came up with commercial lunar payload services. There's 3 objectives for commercial lunar payload services, or CLPS. One is that we want to do great science on the moon. The second is we want to test out technology and engineering for future human exploration in Artemis. And the third is we want to generate a group of companies that are highly skilled in doing these robotic lunar landings so that we can use them as part of our Artemis initiative.
Well, let's talk about that a little bit more. How is CLPS beneficial to the Artemis campaign?
Well, a number of different ways. For example, we will do science at the South Pole with our astronauts in Artemis, and also with robotic explorers. They'll be brought down on CLPS. But we're also going to use these robotic landings, these commercial robotic landings, to do science at places where we won't initially send astronauts. We can use them, for example, this intuitive machine mission that's going on today that'll land in the South Pole region will be one of the first forays into the South Pole to actually look at the environmental conditions to a place we're going to be sending our astronauts in the future. That is, what type of dust or dirt is there? How hot or cold does it get? What's the radiation environment? These are all things you'd really like to know before you send the first human explorers. I'd also say that in the future, when we are flying humans to the moon as part of Artemis, we can use commercial services like CLPS to pre-stage equipment or other cargo so that it's there waiting for the astronaut explorers when they land.
And this is an entirely new approach that uses a privately developed lunar lander. What are some of the most important takeaways on risks but also benefits of a model like this?
So when industry came to NASA about 6 years ago and said, we could do this for you as a service, what they said was they thought it would be less expensive than if we did it ourselves, that they could do it faster than we could set up to do it, and that they could do it more frequently, that they could do more than one mission, you know, every year or two. And so far we've seen is that looks like that's going to be true. What we're waiting to see, such as with the mission today, is can they actually do this incredibly difficult thing? Can they really land on the surface of the moon robotically? This is something which is extremely challenging and difficult to do. The moon has no air. You can't use parachutes or wings to slow down. You have to, in effect, ride a rocket engine all the way from orbital speed, you know, thousands of miles per hour, all the way down to a very soft touchdown speed to land in this place, which is very rough, pretty rugged, in really unusual lighting and communication conditions. So this is not an easy thing we have asked these companies to do, but if they're successful, the upside for American exploration is just so great, we have to try it.
Yeah, absolutely. Those are important distinctions. And thank you so much for joining us here today, Joel. With that, we're going to toss it back to Josh and Gary to preview the landing sequence.
Thanks, Leah. We're following along with Nova-C's descent toward the lunar surface. The lander is continuing to decrease its altitude until the powered descent initiation, an 11-minute braking burn that sets Nova-C up for the final moments prior to touchdown. That time of ignition for PDI, or powered descent initiation, is 5:11 p.m. Central Time, 6:11 p.m. Eastern. The entire landing sequence is autonomous, meaning the lander is in control of every milestone required for a lunar landing opportunity, Gary.
And completing a soft touchdown comes with challenges unique to, say, landing
Estou de volta. Estamos então aí acompanhando toda esta cobertura especial então aí do pouso na superfície lunar da Intuitive Machine, né, com a missão IM-1, aí com o módulo de pouso Odysseus, né, no veículo Nova C. Estamos aí então juntos aí com esta transmissão aí com a NASA, Institute Machine e o mundo inteiro ligados aqui, né? Então aí vamos ver, né, se hoje aí finalmente aí teremos o pouso na Lua, né, após 50 anos aí de espera, né, desde aí da última missão Apolo. Então vamos ver, né, vamos ver se hoje então aí teremos aí o pouso na superfície lunar. Estamos então acompanhando juntos aqui então esta transmissão ao vivo, né? Então, meu nome é William Pessoa. Lembrando que o pouso aí então está previsto para acontecer dentro de 1 hora. Então, pouso aí previsto aí para as 20 horas e 24 minutos, né? Pelo horário de Brasília. Né, isso porque anteriormente, né? Estava mais cedo. Só que eles viram aí e fizeram então uma órbita adicional, né? Uma descida de órbita então adicional. Então, por isso que o horário foi mudando, né? Ao longo do dia. Né? Então aí hoje finalmente culminando aí às 20 horas e 24 minutos, né? Horário então previsto aí para esta tentativa de pouso aí na superfície lunar, né? Estamos então acompanhando juntos esse grande momento histórico, então aí da Institutive Machine e aí com a NASA.
Initiation or PDI. During this maneuver, Odysseus must reduce its
Então
velocity
já
by
iniciou aí o
approximately
PDI, né?
1800 meters per
Aí que é
second. You can think of it as a braking phase.
momento então de começo de descida de órbita.
Using its main engine with the hazard relative navigation or HRN
Vamos
now
então aí
being fed
acompanhar
by
juntos,
NASA's
né?
NDL
Queremos, né?
sensors
Tem
facing
imagens.
toward the area where the
Então
lander
aí
intends
do
to touch
momento
down.
do
At this
pouso,
point,
né?
HRN will
Esperamos
autonomously
que
scan the intended landing
a
site
gente
for a
tenha
safe
imagens
landing
aí ao
area.
vivo, né?
Then, the
Aí
lander's
durante
guidance,
então o
navigation
momento
and
do pouso.
control
Isso aí é
system
só
commands
a
Odysseus to
simulação,
a
né?
point
Como vocês estão vendo.
approximately 30 meters
Aí do
above the
momento
designated landing site,
aí
and
do
the lander
pouso,
goes
né?
into a vertical
Isso aí
descent,
é a
followed by
simulação de
terminal
como será
descent.
então aí o pouso
Intuitive
na
Machines
superfície
created Nova C for the CLPS initiative
lunar.
and commercial enterprise with the goal of
Lembrando
creating
então que
a lunar economy.
esta missão em conjunto também com a CLPS, né? Aí para então aí a futuras missões automáticas de entregas, né? Aí de missões automáticas, como se fosse, por exemplo, aí a Amazon, né? Por aí vai, né? Então aí futuramente, aí então teremos missões aí automáticas, né? Para entrega de carga, né? Para a Lua, por conta aí da missão Artemis, né? Então aí temos aí dados aí do Odysseus, né? Tem aí 4,6 metros de diâmetro, né? De comprimento, 4,3 metros de altura, 1,6 metros aí no seu topo, peso aí de capacidade de carga 130 quilos, e aí temos aí alguns componentes, né? Componentes aí do hélio, né? Parte do hélio, de hélio, e aí temos aí a parte dos combustíveis líquido, metano e oxigênio líquido. Então é a parte aí dos combustíveis. Então lembrando que esta missão tem apoio aí da CLPS, né, Commercial Lunar Payload Services, né, da NASA, né, e aí para as próximas missões Artemis. Estamos então aí transmitindo esta tentativa de pouso após 52 anos aí desde a última missão Apolo. Então aí pelo horário de Brasília agora são 19 horas 19 minutos, faltando então aí pelo cronômetro deles 1 hora e 4 minutos para o pouso. Então aí nesta cobertura especial do pouso da superfície lunar. Então vamos aguardar então aí os momentos aí de descidas de órbita da Lua, né? E a confirmação também do pouso, né? Queremos aí tem imagens, né? Também aí durante a descida aí do Odysseus, né? Vamos ver se teremos imagens então aí do Odysseus. Então temos aí a parte do Intuitive Machines.
We're here to talk a little bit about the Lunar Data Network. This is a private deep
Machines,
space
né?
network.
Depois, logo depois, né? Vamos aí mostrar para vocês como foi então esta cobertura aí, né? Aí os melhores momentos, né? Na íntegra do pouso, como foi feito pelo Slim, né? Onde eu trouxe para vocês então a cobertura completa na íntegra, né? Aí do momento então do pouso do Slim. Então aqui na NASA, né? Intuitive Machine também aí. Vamos aí trazer para vocês então, este momento então, total do pouso, né, na superfície da Lua.
Not only with Artemis at 430,000 kilometers, but also with the
Estamos então aí essa aí é a simulação, né? Estamos com velocidade neste momento de 5,6 milhas por hora de velocidade. Estamos aí então indo bem, né? Aí até o momento, sem nenhum problema.
You need to be able to have a relay satellite. So we're going to put relay satellites in orbit.
Então, distância aí em relação à Terra, né? Entre a Terra e a Lua, estamos aí com 3.900 mil quilômetros, né, de distância. E do Odisseus em relação à Terra, né, em relação à Lua, estamos aí com 192 quilômetros. Não, quilômetros, né, de distância. Então ele segue aí fazendo a sua descida. Nós vamos acompanhar juntos aqui, então, este momento da descida do Odisseus na superfície da Lua.
But we think it is the future of humanity in lunar space.
Thanks so much. It's really exciting to see this in action. And we are just minutes away from acquisition of signal to confirm deorbit insertion. So we're going to send it back over to Josh and Gary to follow
Então aí
with the
tivemos a
operations.
confirmação de inserção de órbita.
Thanks, Leah. That lunar data network information
A
feeds into
confirmação
Nova
aí de
Control's
inserção de
communications
órbita
and ground
confirmada.
network console screens. It's just one of many different screens that are used
Uma
by
hora
the
para o
flight controllers,
pouso.
and we want to bring you closer into the
Lembrando
mission
então que o pouso
and
então aí
into
está
our mission
previsto para
operations
acontecer
center.
às
Let's take a
19
look
horas,
at what flight controller
às 20
teams
horas e
are
24
seeing now.
minutos.
This
E
particular
aí temos aí
screen is called
os sinais aí de
Deorbit
dados
Descent and Landing, or
do
DDL
Odisseus,
screen. This
aí
screen
para
is primarily
vocês.
used by the mission director and landing system experts.
Então, em dados
It's
de
used
telemetria
primarily
do
while Nova C
Odisseus.
orbits the moon and through landing. The top right images of the moon are called the lunar tactical view. When the dots turn red, the lander is on the far side of the
Lembrando
moon,
que o pouso
and
então do
green is on the
Odisseus
near
será
side.
feito aí
The
na
line
região do
is the
Polo
tail
Sul,
where Nova C
aí
is,
da Lua.
with each dot representing 10 minutes of elapsed time. The acceleration sensed portion of the screen shows raw acceleration values from Nova C's inertial
Então, esses são
measurement
dados aí
unit.
de
This is used a
aceleração,
lot during burn maneuvers and is a more
né,
robust way
esses
of
dois
measuring
gráficos aí que eles
acceleration over
estão
time,
apresentando,
with the
né, são
ability
dados
to
aí
look
de
back at what has
aceleração.
happened. For some reason, flight controllers have lost data. Finally, the column on the right is a received, accepted, edited, and failed pre-checked, or RAFE chart for short. When each of these lines are on top of each other, that's a good indication that Nova C's navigation system is in
E aí
good
é parte
health.
então de
That's
dados
because
de
every
navegação,
measurement
né?
Nova
Então
C
esses
makes must be received,
gráficos aí que eles
accepted,
estão
edited,
apresentando
or
agora
failed
são a parte então de
pre-check.
dados
The
de
failure is a possible
navegação.
outlier of data that the lander's computer automatically knows is bad information. Collectively, the DDL screen is one of many data displays that flight controllers are monitoring to successfully navigate Nova C to the lunar surface.
Uma hora para o pouso. Estamos na sala então de controle do IM-1, é a nova C IM-1. É na sala de controle aí, Nova Control. E lá vamos nós, né? Estamos aí nos preparando então aí para a descida de órbita, né?
Around 4:45 p.m. Central Time. The next critical milestone is powered descent initiation at 5:11 p.m. Central. This burn is the first in a sequence of maneuvers that starts about 12 minutes prior to landing, or about 50
Estamos aí
minutes
então
from
já
now.
praticamente estão iniciando as sequências de descida de órbita, né? Estamos então acompanhando todos os detalhes ao vivo aqui então para vocês, na descida então do Odisseus até a superfície da Lua. Esperamos aí que tenha aí o pouso, né? Firmado daqui a 58 minutos, às 20 horas e 24 minutos. Lembrando então de deixar o like aí na transmissão, de se inscrever no canal, de compartilhar, o mundo inteiro então está de olho aí neste grande momento histórico aí da NASA, né, do projeto Artemis, do também aí da CLPS, né, aí da Commercial Lunar Payload Services, né, lembrando aí que futuramente então aí teremos aí missões automáticas, né, para entregas de carga aí para a Lua, né, para servir então as futuras missões Artemis, né? Então esse é um passo super importante aí então para este projeto de retorno então do homem de volta à Lua, né? Então por isso que tem todos esses preparativos aí para que nós aí possamos retornar aí à superfície da Lua. Mas lembrando que a tripulação então da Artemis 2, né, que já foi selecionada, ela então só vai embarcar aí no CLS só ano que vem, 2025, em setembro de 2025. Mas esta missão só irá circundar a órbita da Lua. Ela não fará ainda o pouso. Ela só fará aí assim, vai só apenas dar a volta na órbita lunar. Então finalmente aí eu consegui, né, aí chegar a tempo, né, para poder transmitir então esta missão para vocês. Lembrando que ainda nesta madrugada de hoje teremos aí a missão Starlink, é isso mesmo, a missão Starlink número 140 do grupo 715, no dia 23 de fevereiro, então na madrugada de amanhã, aí a partir das 1h da manhã, missão Starlink então aí para vocês. Tá? 56 minutos. 56 minutos para o lançamento, para o pouso. Lembrando que esta missão então começou no dia 15 de fevereiro, aí com o lançamento então da SpaceX, aí lá no complexo de lançamento número 39A, do Centro Espacial Kennedy. Nós acompanhamos aqui então esta missão aí com a SpaceX, né, que foi na madrugada do dia 15. Então aí teve um lançamento então, realizado com sucesso. E agora, finalmente, então aí o nosso pouso tão aguardado dentro de instantes, né? Então aí estamos então acompanhando ao vivo, né, os momentos então aí que antecedem o momento então do toque na superfície da Lua. E vamos aguardar então aí este grande momento histórico, né, onde o mundo inteiro aí está acompanhando também. Então vem chegando na transmissão para acompanhar junto com a gente. Não se esqueça também de seguir o canal nas redes sociais, né? Os links do canal estão aí na descrição aí da nossa transmissão.
Frequency mass gauge or RFMG.
Aí ele está apresentando os instrumentos, né, presentes aí no Odisseus, né, mas logo depois, quando tiver concluído, né, no dia de hoje, eu vou lá no nosso blog, né, inclusive o link está na descrição, eu vou descrever aí os instrumentos que estão lá para vocês aí do Odisseus, tá? Então não se preocupe, que lá vai estar detalhado então os instrumentos lá do Odisseus, né? Que está aí a bordo do Odisseus. Lembrando então que estamos com a nossa transmissão ao vivo, né? Eu pensei que não ia conseguir tempo para chegar, né? A sorte que então mudou os horários, né? Era para ter sido mais cedo, mas eles adicionaram então mais uma órbita, né? Aí durante o dia, e aí então aí foi alterando para agora às 20h24 da noite de hoje, né? Então aí previsto então para o toque na superfície lunar, então aí do Odisseus. E vamos aí acompanhar juntos então este momento então do pouso do Odisseus na superfície da Lua. Agora, então, pelo horário de Brasília, são 19h31 minutos, faltando então aí 53 minutos para o momento então, do toque na superfície da Lua. E vamos aí acompanhar juntos esse grande momento. Então já agradecendo então aí a audiência, né, os likes, então as inscrições, estamos perto então aí também dos 1.240 inscritos aqui no canal, para agradecer o apoio, né, de todos vocês aqui nesta transmissão.
Back in 2018, the U.S. government declared the moon of strategic interest. At that time, few companies and institutions were working on payloads designed for the moon because no one had been to the lunar surface in over 50 years. Gary, in the time it takes to get an undergraduate degree, 6 commercial entities created payloads for the IM-1 mission. We'll view all of them as pioneers helping shape this brand new
esperança, né?
lunar economy.
Expectativa,
And Josh, a true lunar
ansiedade.
economy should not have just NASA
E
as a
depois de
sole customer.
52
NASA's
anos,
CLPS initiative
aí então
encourages
desde
a
a
model
última
where NASA
missão
is just
Apollo,
one of many customers. And this is an
então estamos
important
retornando aí à
element to
superfície
ensure
da
that
Lua.
this model of transporting incredible science and technology instruments to the lunar surface is a sustainable and robust one.
Well, it's important, and Gary, it's also promising in this situation. The commercial interest for delivering science and technology
Era para ter
demonstrations
sido com
continues to
Peregrine, né?
grow.
Mas
As of our
infelizmente o
third
Peregrine,
planned mission,
né, não
we're seeing
conseguiu
more and
chegar,
more
né? Quer dizer, ele
non-CLPS
chegou,
payloads
mas
from both
ele teve que
domestic
voltar
and
aí por conta
international
daquela
companies and institutions,
avaria,
which are
né, que
driving us towards a
aconteceu aí
future maybe
lá com o
completely
seu
commercial mission to the
tanque
moon,
de
possibly
combustível, né?
as soon as our
Então aí
fourth
por isso
mission.
que não
Well, even on
teve o
IM-1, there's
pouso
a
lá do
variety of unique
Peregrine na
commercial
superfície
payloads.
da
It's a
Lua.
good snapshot of out-of-the-box ways to think about what the moon can offer.
Well, that's
Mas
part
até o
of the
momento, então,
challenge beyond just
o
creating the
Odisseu
capability
segue
to
aí
land on the
descendo,
moon
então fazendo
safely.
as suas
We had to look
a
toward a new
descida de
emerging
órbita,
ideas
segue
and find
tranquilamente até o
innovative
momento,
ways that may add
sem
value
nenhum
on
problema.
Earth and spaceflight. Let's learn a little bit more about those payloads and the lunar lander attempting to make history. some of the hardest challenges in the world, and certainly right now for us, this is one of the hardest challenges on the moon, most certainly.
Which we are saying absolutely, and it takes everybody in this room, and everyone has their
Estamos então aí de olho, né? Aí todos os movimentos aí do Odisseus, né? Neste momento então aí crítico aí para o momento aí do pouso aí na superfície da Lua, né? Agora pelo horário de Brasília são 19 horas 38 minutos, né? Você está acompanhando ao vivo então esta tentativa de pouso aí do Institute Machine aí pela missão IM-1, né? O Odisseus, né? Então aí 45 minutos então aí para o momento do pouso, né? Lembrando que o pouso então aí será na superfície da Lua, então no Polo Sul. Estamos então aí transmitindo tudo para vocês.
Thank you so much for joining us, Ben.
It's great to be here.
Now tell me a little bit about this landing site. Why was it chosen?
Então nesse momento aí o Odisseus, né, segue aí então em sua descida, né, de órbita e de sua trajetória normal até o momento, né, sem nenhum problema. Então aí estamos então acompanhando juntos com você. Então temos aí a sala de controle aí do Nova C, sala de controle aí então do Nova C para vocês. Aí tá pela missão então IM-1. Lembrando que logo depois, então assim, né, tem que terminar então essa transmissão lá no nosso blog. Você então verá aí os detalhes, né, aí do Odisseus, né. Vou tentar trazer para vocês aí todos os detalhes do Odisseus, dos instrumentos, né, que ele está levando, né. Lembrando então que ele mede, né, de comprimento 4,6 metros de comprimento, de altura 4,3 metros, tá? E ele pode então carregar aí na sua carga, em torno aí de 130 quilos, né, de peso, aí então de carga útil que ele pode transportar. Lembrando que esta missão aí tem aí então em colaboração junto com a Lunar Payload Services, né, da NASA, né, para o projeto Artemis, que futuramente então aí levará missões automatizadas, né, para a superfície da Lua, né, para futuras construções aí de base, né, na superfície lunar, então aí. 43 minutos então aí para o momento do toque no solo da superfície da Lua. Estamos então aí nos aproximando aí do momento aí derradeiro, né?
To about 10 degrees, about 300 kilometers from the pole, and we think that's a good location because it's the closest to the pole that anyone's landed.
Lembrando então que esta missão teve início com a SpaceX, né, com o lançamento da SpaceX lá no complexo de lançamento número 39A, no Centro Espacial Kennedy, foi no dia 15 de fevereiro, na data do dia 15 de fevereiro, então nós transmitimos aí a missão com o lançamento então da SpaceX, né, e hoje aí o seu pouso na superfície da Lua.
Close. So that's one example of something we can do in support of Artemis.
Well, thank you so much for joining us here today, Ben. That's all the time we have right now. We're going to send it back to Josh and Gary to talk a little bit about the landing sequence.
Thanks, Leah. Yeah, Malapert A is a fascinating satellite crater to Malapert, a crater only 300 kilometers from the moon's south pole. The site is named after Charles Malapert, a 17th century Belgium astronomer. The area around the landing
Estamos aí
site
então
is
nos aproximando
believed to be made of lunar
aí
highland
da
material,
superfície, né? Então aí
similar to
temos
Apollo
missões,
16's
foto
landing
então das
site.
missões
Apollo
Apollo aí,
16
né, para
was the
vocês,
first Apollo mission
imagens,
to visit the lunar
né, das
highlands
antigas
in an
missões aí
area
Apollo.
called Descartes. Scientists believe the highlands offered insights into the moon's early history. The Descartes landing site turned out to be a source of rich scientific information. A large sample of rock called anorthosite was recovered from Descartes, which solidified more than 4 billion years ago during the moon's formation, when the outer regions were still molten. The IM-1 mission is carrying NASA payloads that may help better characterize this important scientific landing site for future Artemis missions.
Estamos aí então nos aproximando aí cada vez mais aí da superfície da Lua. Momentos aí então de expectativa para este grande momento. Estamos aí a 83 mil metros de distância então da superfície lunar, né? 82 agora, 82 quilômetros, 82 mil metros. É como vocês podem observar ali na sua tela superior ali direito, né? No canto ali superior direito. 80 metros, 80 mil metros de distância. Né, estamos aí com a descida aí controlada, né, até o momento indo bem aí com esse momento então da descida controlada, essa descida de órbita. Momentos aí então de expectativa, lembrando que estão aí com dados então de telemetria, né, do Odisseus. 77 mil metros. 77 mil metros de distância.
So during the last 2-hour orbit, flight controllers have been loading software patches and resetting the lander's guidance, navigation, and control system to use 2 laser beams from NASA's Navigation Doppler LiDAR as primary navigation sensors to land Odysseus.
That's right, and we're coming up on the timeline for when Nova-C is about to begin the activation of NDL. This is a 3-step process from powering on, becoming ready for operation about 5 minutes later, and then integrating those sensors with Nova-C's terrain and hazard relative navigation cameras ahead of Nova-C landing. So while we wait, let's learn a little more about NDL.
So the Artemis program is taking NASA back to the moon, and everything that goes there, including the instruments and people, must be flown there safely.
And we just got an update from one of the flight controllers that the HRN and TRN cameras assigned to Nova-C are still nominally processing images using 2 of those NDL lasers. Quite the feat, Gary.
No, it's absolutely incredible and a very important milestone to reach. Now, with that understanding, let's learn more about how this technology is playing an active role in this dynamic situation. Let's head over to Leah Cheshire. Leah?
Thanks so much, Gary. I'm joined now by Prasan Desai. He's NASA's Deputy Associate Administrator for the Space Technology Mission Directorate. Thank you so much for being here.
Grateful to be here.
So let's talk a little bit about the novel landing technology that is NDL. Can you explain that to us?
Yeah, so NDL stands for Navigation Doppler LiDAR. And one of the challenges for doing any space missions is knowing where you are and trying to figure it out, right? And so we're looking to develop newer and newer capabilities that we can do that more precisely and that take up less volume and mass on the spacecraft so that you can have all the available payload mass for instruments and other scientific things we're trying to do. And so this is the next generation of a new capability where we're trying to go from the traditional measurement using radar to a laser-based system. And so that's what this navigation Doppler LiDAR will be doing, is sending out 3 laser beams to try to get the velocity measurements in the lateral direction as well as the vertical direction.
So when it comes to NDL, what are some of the challenges we expect to see when using this technology?
So we've tested it on the ground in a number of platforms, from helicopters to landers here on the surface, on the Earth, to test this out. But this is the first time we're going to test it actually in the space environment on a
Vamos ver agora
right?
quantos
And so we will
mil
see how
metros
that,
estamos, então
different
aí quantos
environment will really
quilômetros
affect
aí
the systems,
estamos
right? And so,
da superfície da
one of the
Lua.
things that
Estamos
we
agora
really
neste
want to know is
momento
what
com
the,
aí
how the pulse
58,
comes back after they send the
57
laser, and so
quilômetros
we're
aí
trying to
da
assess how long
superfície
it
da
takes to
Lua.
process and how it
Estamos
will,
indo bem.
help,
Estamos aí
define the
acompanhando aí
solution
todos
to
os
figure out the
detalhes então aí do
trajectory to go down
pouso
to landing on the
do
surface.
Odysseus
Now,
na
this technology has
superfície
become
da
a little more
Lua.
critical for today's mission. So can you talk about how
Estamos aí então aí acompanhando
NDL is now
ao momento
being
então
used
da
in
sua
today's
descida de
landing?
órbita. Estamos aí a 56 quilômetros da superfície, ou 56 mil metros, né? Estamos aí então
the velocity and altitude information so that the lander can land safely on the surface. And that's important because as the lander comes close down, we don't want it to tip over. And so we need to get an understanding of the vertical velocity so it knows how much thrust to slow down, but also the lateral velocity, because if it comes down sideways too much, it can tip over and fall. So by knowing the velocity, the lander can decide exactly how to come down and hover, basically slowly to come down, and that's why it's really important to do this testing. But here we are today, we're going to try it for the first time in line, and so we're excited for.
Estamos então acompanhando juntos aí esta transmissão, aí no momento então da descida, estamos aí indo bem até o momento na sua descida de órbita, aí do Odysseus, daí da Intuitive Machines, né, a IM-1. Vamos ver se hoje aí ocorre tudo bem, né? Talvez, né? Não querendo criar expectativa, mas não sei se, né? O que vocês acham então aí, né? Se vai ou não espatifar? Acredito que não.
The thrust is going to throw up all this ejecta of the lunar regolith thing. And so we have 4 stereo cameras.
Acredito que não vai se espatifar no solo, né? Acredito que ele vai pousar suave. Então, para saber isso, né, se vai ou não pousar suave, você tem que acompanhar aqui na nossa transmissão, aqui no nosso canal UPTV, 19 horas e 50 minutos pelo horário de Brasília. Então aí o Odysseus segue descendo de órbita, aí bem tranquilo até o momento, faltando então aí 33 minutos para o pouso na superfície da Lua.
It's no secret that landing on the moon is challenging. Countries around the world have attempted.
Então, como ele falou ali, não há segredo para pousar na Lua, sim, é um desafio. É sempre um desafio, então, fazer o pouso na Lua, né? Como a gente já acompanhou aqui alguns desafios anteriores, né? Como, por exemplo, da sonda Raptor, né, que se espatifou. Também aí da Luna 25, também da Rússia, né, que se espatifou. Também aí tivemos aí o sucesso da Chandrayaan, né, 3, que a gente viu aí, acompanhamos aí também. Tivemos o sucesso aí da última missão também do Slim, né, também aí pousando com sucesso, né. Então, como ele falou, né, pousar na Lua não tem segredo, é desafio. Lembrando que esta missão é super importante, então, para as futuras missões aí do projeto Artemis, né? Então aí em parceria com a CLPS, né? Commercial Lunar Payload Services, também aí em conjunto com a NASA. Né? Lembrando que futuramente então aí teremos missões automatizadas, né? Para entregas, para a construção da base então na superfície da Lua. Então, o nosso objetivo aí de retornar à Lua é esse, né? De construção aí da nossa base e de poder aí seguir mais além, né? Até que tem o projeto The Moon and Behind, né? Ou seja, ir da Lua e mais além. Lembrando que o pouso, então, está programado para acontecer às 20 horas e 24 minutos, hein? Então, estamos chegando perto, né? Estamos aí abaixo já de 50 quilômetros de altitude, né? Em relação, então, à superfície da Lua. Lembrando que o pouso, então, vai ser na superfície, ali na... Desculpe, na região, então, do Polo Sul, né? Da Lua. Então, aí vamos seguir juntos aí até este momento final. E o recebimento também das primeiras imagens. Agora, horário de Brasília, são 19 horas e 53 minutos. Lembrando que na madrugada, então, do dia 23, aí a partir então, da 1 da manhã, teremos então a emissão Starlink do grupo 715 lá em Vandenberg, na Califórnia. E vamos então acompanhando juntos também esta transmissão lá na Califórnia. É para você então não perder nenhuma programação do nosso canal, né? Peço que se inscreva, lógico, aqui no YouTube e também nas nossas redes sociais, lá no X e também no Instagram. Nós já estamos nos chegando então aí a marca de 1.240 inscrições no canal.
Working diligently over the past 7 days to take us this far, and are laser focused on the operations ahead.
Acompanhando este
Following the
momento
clock
histórico,
down to the start of
então
those
aí do
autonomous
pouso na
operations of
superfície da
Novacy,
Lua.
starting with
E
the
passamos
powered
então da
descent
marca de
initiation.
1.240
For now, we're heading
inscrições
back
aqui
over
no
to
nosso
Leah
canal.
Cheshire, who's standing
Né?
by
Quero
with
agradecer
NASA's
então aí a
associate
todos pelo
administrator.
apoio
Leah.
em nossas
Thank
transmissões.
you, Gary. I'm joined now by Jim Free, NASA's Associate Administrator. Thank you for joining us, Jim.
Thanks for having me.
This is a big day, and what are some of the challenges to landing on the moon that people might not expect?
Well, it is a big day.
Tá chegando, hein?
Yeah, you're right.
Tá chegando esse grande momento aí, né? Expectativa, ansiedade. E vamos então acompanhar tudo aqui ao vivo para vocês, né? Estamos então aí já, como eu mencionei, né? Estamos abaixo já de 50 quilômetros de altitude, né? Em relação então à superfície da Lua. Ele segue aí em descida de órbita, né? Tudo tranquilo até o momento. Estamos aí nos aproximando então aí do momento do pouso, então do Odisseus.
So how does NASA help ensure success while we also allow these companies to figure out their solutions?
Lembrando que o pouso então será aí às 20 horas e 24 minutos, né? Houve então essas alterações de horário, né? Por conta justamente aí dele então esse adicional de órbita. Estamos aí já a 20 quilômetros de distância, deixa eu conferir aqui, isso, 26 quilômetros de distância aí da superfície da Lua, 20 quilômetros, 26 quilômetros agora. Estamos aí indo bem, 25 quilômetros de distância. Estamos aí descendo bem, sem nenhum problema. Faltando aí 27 minutos para o toque no solo.
So we started back in space station, where we started with the commercial cargo, where we
momentos de expectativa aí então para esse momento então aí para o toque no solo aí do Odisseus. Agora pelo horário de Brasília são 19 horas e 56 minutos. Você está assistindo então ao canal Will PTV, trazendo para vocês então aí este momento do pouso na superfície da Lua, lá no Polo Sul. Então aí do Odisseus, da Machine, da missão IM-1.
But Eclipse is absolutely essential for Artemis. It's our first steps of understanding the lunar environment. So the Intuitive Machines lander is going to help us understand how the lunar dust moves as the rocket plume, the exhaust of the rocket hits that dust. We need to understand that because we're going to land even bigger landers with our humans in the future, and we want to land it close to our other elements, so we're not blowing that dust everywhere. How does it behave? So that's just one part of it, but it is our first step of understanding that environment that we're going to put our astronauts on the surface.
And of course, we're really, really looking forward to that mission. But for now, thank you so much for joining us here today. We are going to go back to Gary and Josh to highlight some more payloads ahead of the powered descent initiation.
Hey, thanks, Leah. A report at 4:54 p.m. Central Time from the flight control teams shared that Nova C is less than 30 kilometers above the lunar surface and is in the lunar southern hemisphere. We're still on track for PDI at 5:11 p.m. Central Time. Nova C
Estamos aí nos aproximando, então aí do momento do pouso, faltando menos de 25 minutos e 40 segundos. Então aí para o momento do pouso na superfície da Lua, né? Então do touchdown.
5 of the 6 NASA payloads so far throughout our broadcast today. Let's talk about the final NASA payload, LN-1. Lunar Node 1, or LN-1, is a small CubeSat-sized flight hardware experiment that integrates navigation and communication functionality for autonomous navigation to support future lunar surface and orbital operations.
Lunar Node 1.
Então, como eu falei, né, mais tarde, então eu vou colocar tudo para vocês detalhado lá no nosso blog, né? Aí os instrumentos, né? Aí as cargas que estão a bordo, então aí do Odisseus, tá? Não se preocupem. Então, para acessar o nosso blog, o link, né, se encontra aí na descrição da transmissão. Tá chegando.
LN-1 will test a lunar navigation concept of operations with the implementation of MAPS, or the Multi-Spacecraft Autonomous Positioning System. Ideally, this kind of technology can support a network of
20 horas pelo horário de Brasília, faltando 24 minutos para o pouso, para o momento do toque no pouso na superfície da Lua. Estamos aí então acompanhando ao vivo este grande momento histórico após 52 anos desde a última missão Apolo, né, onde vamos então aí retornar à superfície da Lua, né, no caso aí dos Estados Unidos, né, então irá retornar à superfície da Lua.
It started as a challenge from our CEO Steve Altemus to his alma mater, Embry-Riddle Aeronautical University. Students and faculty created EagleCam to take an out-of-this-world selfie of Odysseus landing on the moon. The camera system could capture the world's first ever third-person picture of a spacecraft making an extraterrestrial landing. The camera system is designed to deploy off of Nova C approximately 30 meters above the lunar surface and take images of Odysseus during landing. Additionally, the device will test a dust removal system which could lead to the future advances in spacesuit technology. As part of this project for EagleCam, Embry-Riddle teamed up with NASA's Kennedy Space Center to demonstrate the NASA-developed electrodynamic dust shield, or EDS.
Então, para quem está chegando agora, estamos aí acompanhando ao vivo o momento então do momento esperado, então ainda do pouso do Odisseus aí na superfície da Lua, lá na região então do Polo Sul. O pouso então dentro de 22 minutos, né, irá acontecer então o momento do pouso dentro de 22 minutos pelo horário de Brasília, marcado então aí às 20 horas e 24 minutos. Né, estamos aí acompanhando todos os momentos então aí da sua descida de órbita. A última verificação que nós estávamos, né, estávamos então aí já abaixo já de 20 quilômetros então aí em relação à sua superfície. A cada segundo então aí a gente desce mais e vai descendo.
SpaceX's second stage. Out of all of those images that were taken, we ended up with just 4 inspiring ones to show humanity's place.
Lembrando que logo mais, então, na madrugada do dia 23, a partir das 1 da manhã, vamos acompanhar então a missão Starlink número 140 do grupo 715.
Thanks, Josh. I'm here now with Nikki Fox, NASA's Associate
Então aí não
Administrator
teve
for the
nenhuma
Science Mission
alteração
Director.
no
Thanks so much
momento,
for
então
joining
aí
us.
Thanks for having me. This is a great day.
It is a great day.
na
And
missão
you're
então da
watching this with leaders
SpaceX,
from
né, tudo
NASA
segue
and
em
intuitive
ordem
machines just
para
very
o
close
início
to
da
here.
transmissão a partir da
What's
1h da
happening
manhã.
in the room right now just before these final descent maneuvers?
Oh, there's just excitement, anticipation. You know, everybody knows landing on the moon, going to the moon is hard. And we're already celebrating because this mission is already a success. You know, we've launched, we had a beautiful launch. We've taken great science data all the way, every single
21 minutos, hein? Falta 21 minutos para então o toque na superfície da Lua.
You know, minutes away from starting our descent down
Estamos
to the lunar
acompanhando aí na
surface. So for
íntegra para
me,
vocês
so
todos
many
os momentos,
successes with this
então aí
mission already. So just a
o
lot of
Odisseus,
excitement.
I'm
né, em
loving
sua
that.
descida de
So
órbita.
we are working with these American companies in a very unique way. These are challenging goals, and some people would probably consider this a bold endeavor. But what does it mean to you when you look at pursuing challenges in a bold new way?
I mean, you're right. It is bold.
chegando o
It
grande
is a
momento.
new way of doing science. It is a partnership with totally new companies who haven't done these things before.
Estamos também com a
And we are
transmissão
partnering
ao
with
vivo,
them,
junto com a
and
NASA,
they are
em
taking our
baixinho.
science. It's a way
Já
for
vem o
us
mundo
to
inteiro,
get more science and more
né,
technology
ligados
to the
ali,
moon
né, nesse
quickly.
grande
So
momento
it's faster,
histórico.
it's very cost effective, it's very efficient.
E será histórico.
We're on our way. We've got the 6 payloads from NASA, and we're excited to get them down there. With every new thing we do, there's always a challenge.
Então,
there's
lembrando
always
que
risks.
o Odisseus, né, carrega então as 6 cargas aí da NASA, né, 6 instrumentos então aí da NASA.
NASA science, this is exciting because our Artemis missions and our lunar science touches all 5 of our science divisions in
Então eu vou
very
depois
profound
trazer
ways.
para
So
vocês, né,
super
todos os
exciting.
detalhes
You
então,
said
dessas
high
cargas
reward, so I want to talk
que o
for a minute
Odisseus está
about
levando.
the
Tá?
valuable
Tá no
scientific
nosso
insight
blog.
that we can get from the moon. What
Não
is
se
that? What
esqueça,
does
né,
it
de
mean
quem,
for NASA?
quem entrou aqui na nossa
So
transmissão,
much we can do on the moon,
transmissão,
particularly where this one is
deixa o
going
like,
down
né,
to the
não
South
custa nada.
Pole. We think we're going to
Deixar o
find
like.
great volatiles down
E
there.
também,
So as
né,
we
se
get
puder, se
prepared
quiser,
to
né,
send
se
our
inscrever
astronauts
no canal.
there, then we know that there's water there, and we can use that water. Water's very heavy to carry, so it's really great if you can use it on the moon. We can break it up into hydrogen and oxygen, use it for fuel.
Estamos chegando, hein?
Really great
Estamos
for our
chegando.
sustainability, but
Aguenta aí,
also,
Lua, que estamos
this-
chegando.
where they're going is one of the oldest regions of the moon, about 3.85 billion years old. So we can actually learn
É,
about
já para o
what
mês de
our
março, aí no dia
solar system was
1º,
like
teremos
before
aí a
life
missão
started.
tripulada,
Life is very noisy. We're
a
very,
missão da
very
Crew
noisy
8,
here on Earth. The
é no
moon
dia 1º
is
de
just
março,
like
então não
pristine,
percam.
and so we can
É já
really
na
do
semana
some
que vem.
amazing science.
I look forward to learning more about
Vai
it.
no
So
dia
any
1º
final
de
words
março.
before we wrap it up?
Just thank you. I mean, literally, thank you. This is such an amazing team. You know, thank you to the people that put the science and the technology experiments on with us. Those teams. Thank you to the commercial teams that put their instruments on and are riding with us. Thank you, of course, to Intuitive Machines for this just beautiful, beautiful lander, and thank you to SpaceX for a beautiful ride to space. It's such an incredible effort. All one. I don't know. I'm a big bundle of emotion. Go NASA, go Clips, go OD, go Intuitive Machines.
I'm with you all the way. Thank you so much for joining us here today. Now we are following Intuitive Machines flight controllers during Nova C's final descent. So back to Josh and Gary.
Thanks a lot for that, Leah. During that interview for folks at home, we did
Estamos aí
hear
com
that
várias
there was a
imagens
maneuver
aí
to
do
burn
Nova
attitude, which
C.
means the lander is starting to
É,
make
novo
the positional
control.
requirements needed. And we're going to start listening into the IM-1
Essa de
channel so
controle
folks at
então
home
aí.
can hear. We just heard from flight
Odisseus.
controller about 5 minutes until TIG.
Altitude of 10 kilometers, downrange 1,100 kilometers.
10 km de altitude,
TIG,
10
time of
km,
ignition, so we're
10
inside
km
of
de
5
altitude.
minutes.
TIG minus 5-minute deadpans.
TIG minus 5 minutes. We are standing by for powered descent initiation. Gary, this is a critical 11-minute burn to slow the lateral velocity such that Nova C can pitch over for further operations.
Estamos então em
And while
menos
we were
de
in that
10
interview, we did
quilômetros
hear
da
that the main
superfície da
engine
Lua.
gimbal checkout was completed. So now we're focused on the operations with Nova Control. For folks at home, we are listening into the live channel there.
That's right. A lot's happening in Nova Control. We're going to be hearing these
Vamos
status
lá.
calls periodically as we follow the flight control teams that
Agora Agora, pelo horário de Brasília, são 20 horas e 7 minutos.
Lots happening, Josh. Of course, we have this 11-minute burn. We're focused on the propulsion elements of this PDI.
Menos de 16 minutos, então 40 segundos para o momento do pouso.
That it can use a technology called terrain relative navigation to scan the environment along the way. What's happening there?
Right, so we know that we needed terrain relative navigation then when we were descending and coming down to the lunar surface. Now, this involves two pieces. You have a camera and you also have a laser rangefinder. At the top of the show, we started talking about, hey, the laser rangefinder that Intuitive Machines put on Nova-C, it's not operating. We made the decision for flight controllers to utilize 2 of the laser beams from NASA's NDL payload, make the software patches required to reassign those lasers into the TRN and HRN cameras in order to give us an opportunity to land on the south pole of the moon today. Gary, is quite the feat and challenge overcome in just about 2 hours because we elected to delay that orbit and go into another orbit. That's why the show was a little bit later.
Agora tá pelo horário de Brasília, são 20 horas e 8 minutos.
We're talking about beginning
Estamos já aí abaixo de 10 quilômetros da superfície da Lua.
That was just about 20 minutes ago.
The status checkouts of these critical systems are essential to understanding the performance. The folks you see now on your view, this is Nova Control. They're monitoring every step and all the data coming from Nova-C ahead of PDI, which is scheduled just a little bit after 5:11 p.m. Central Time. Exactly what are these folks looking at, Josh?
Well, right now everyone's looking at their assigned screens, and all of them are tailor-made. Generally, there's a few who are looking at the same type of screen, but they're tailor-made for their task. You have Spark looking at electronics, things like how hot are the electronics, payloads are monitoring different parts and pieces.
Para acontecer às 20 horas e 24
degrees
minutos.
left until burn attitude. The vehicle is still getting ready for this PDI ignition, which we expect here.
Estamos aí com a nossa
in just
transmissão
about
ao vivo
2 minutes, Gary.
para vocês. Estão trazendo todos esses detalhes.
Everyone's looking at their
Aí então nesse
screens and
momento do
doing their
pouso.
respective jobs and reporting up into the mission director, while the activity
Ainda aí
director is keeping
do
in touch with
Odysseus.
everybody and making sure we're putting this whole thing together. Press started. There's a call for tank press started. Just a little bit before that, Gary, we did hear that they were working on the cryo fill. So these are all steps that are leading towards PDI, powered descent initiation. We expect that to take about 11 minutes, where we're slowing Nova-C's velocity approximately 1,800 meters per second, and that's required to get this lunar landing
Agora estamos
opportunity.
então aí no momento da descida final aí, né? De órbita.
seconds to take. Propellant tanks at flight pressure.
All right, 90 seconds until we begin that propulsive maneuver. Again, power descent initiation is about a 10 or 11-minute burn that will slow the spacecraft's descent.
Lembrando que dentro de instantes então teremos aí o início então da descida de órbita, né, com a ignição aí do criogênico.
Rapid succession, pitch over, vertical, and terminal descent.
And we just heard another call out from the prop console saying that feed line prep is complete. What that means is Nova-C's propulsion system, that mixture of liquid methane and liquid oxygen, that feed line is prepped, getting ready to go into an injector to
combustível
blend
aí do
those two
metano
propellants
líquido
and
e
propellants in the
oxigênio líquido.
oxidizer and have ignition of PDI. We're tracking that in just under a minute, Gary.
Converging on burn attitude.
Lander is getting into the correct attitude required.
Line prep complete both sides.
Another call for feed line prep complete for liquid methane and liquid oxygen in preparation for this PDI burn.
Estamos aí então na expectativa então de início da ignição, então aí os motores estão com oxigênio e hidrogênio líquido.
15
é um
seconds exec
PDI.
mode.
15 seconds to exec mode. We're tracking a little less than a minute, though, until the time of ignition for power descent initiation.
Settling. Ignition.
E temos ignição. Temos ignição.
Main stage.
There we heard main stage ignition. That's coming from our prop console, Rob.
Temos ignição então aí do estágio então do PDA.
GNC call on good control.
Thrust to weight 1.5.
These are great call outs in between our prop console and our flight manager, Scott Tamblin. calling it as
20 horas 11 minutos. Pelo horário de Brasília, estamos então acompanhando o momento então aí de descida. Já estão utilizando aí os tanques de hidrogênio, de metano e oxigênio líquido.
But that's why we have this autonomous lunar lander. You know, we program, we know that, hey, we want to light PDI in this moment. These are the steps you need to get there. But from here in, this is an autonomous lunar lander, and flight controllers are monitoring communications and tracking the progress right along with the public right now with us.
Nova C has the helm. It is in control and is making the decisions necessary to ensure a soft landing. We heard call-outs about thrust, full thrust right now. There is the ability to throttle that thrust, and we'll see that throughout the descent as the fuel tanks continue to unload and we expel that propellant.
And we did have a few questions come in about how much gas are we giving this to slow down the vehicle. And we want to remind folks that this PDI burn goes
Commanded thrust 90%.
Goes in just about 90% right on time.
90%.
So it goes in 90% in order to, if the lander makes a decision and says, I need to slow down more and make a decision to make a safe landing, it's able to add a little bit more oomph and make that decision a reality.
Então temos o momento da simulação então do PDI.
Fido, I'm showing 500 kilometers to target, but my display is a little bit stale.
That's the mission director Tim Crane calling about 500 kilometers, but stating that
5
his information
quilômetros.
might be just a bit stale.
1,000 psi.
Estamos então a 5 km da superfície.
It's part of the reason we're showing this animation, Josh. Of course, this is not telemetry driven. We're just showing you exactly what's happening. As we hear the calls, this information is relayed through the audio loops. Not enough bandwidth to do a live stream of this. So
Então em 10 minutos para o pouso.
fed from Nova C to Nova Control.
Yeah, that data is going into the flight controllers, and what you're seeing on your screen right now is just to give you an idea of the vehicle's attitude. You heard them talking about moving to a burn attitude. This is what we expect Nova C is doing right now. It is a simulation in the large screen just to give you an idea of what's happening over these critical approximate 10, 11 minutes of PDI, powered descent initiation, trying to slow Nova C down, bring that acceleration down to about 1,800
Vamos agora então
meters per
fazendo a sua
second.
descida,
And
né,
there's some
controlada.
follow-on steps
É
after
bem
that, Gary. It
devagar.
involves pitching over the lander using that gimbaled engine.
Para não
We
ter
heard the
problema.
maneuver to burn attitude followed by main engine gimbal checkout. So they'll use that gimbal to pitch the lander over and start a vertical descent. This is where we start
20
getting a
horas
little tricky as
14
far as there's a
minutos.
final approach. It may add a few seconds, it may add a little bit of time, but we are intended to land right around 17:24. That's 5:24 p.m. Central Time. But know that there is some give and take. We're also expecting, plan for, and train for a little bit of loss of communication during this process.
That's right. And that communication is absolutely important. And part of the reason, and we've been stressing this, Josh, is the autonomous operations of Nova C. Part of that
9
is when
minutos para o
after it
toque no
performs
solo.
that pitch over maneuver.
400 seconds to go and braking 1. Good control.
4
I
quilômetros.
see TRN depause processing in flight.
All right, that was the call that we were waiting for. That was our major problem we've been working on in this dynamic situation, is getting those images processed from the
Estamos então a
HRN
4
camera,
quilômetros da
TRN camera,
superfície.
which in this case, a dynamic situation, we had to improvise a little bit and reach into those 2 laser beams from NDL, figure out a patch while we were in lunar orbit, just about 2 hours, and it sounds like we are getting good readings from those images. Absolutely remarkable feat. We also happened here, I think it was 400 seconds remaining. That was coming from Fido and Flight Dynamics. Sean Stewart working the console this evening.
This is excellent calls to hear. Hazard relative navigation is going to be used after the pitch over maneuver. This allows Nova C to make some decisions and scan the landing site underneath it and make decisions in an area that calculates the terrain to make sure that it's landing in a safe landing zone.
Right, so we finish up PDI, pitch over, and we have to use that hazard relative navigation, a critical tool in order to land on the moon, to make those decisions, right? There's no human eyes, human elements deciding, okay, I see the hazard, I need to steer this way, or maybe press the gas, press the brakes. This all happens autonomously, and this is a huge requirement and a great call out to hear about the HRN camera system and processing those
Estamos aí
images.
então na descida
Right
já
now, I'm
controlada,
tracking
aí na descida bem
516
devagar, né?
p.m.
Estamos já abaixo de 4 km da superfície da Lua. Faltando então aí 7 minutos para o momento então aí no seu toque no solo.
Or about 300 seconds to approximate those
Estamos
numbers.
então
Very
acompanhando o
precise.
momento da descida final aí do Odisseus. Agora, pelo horário de Brasília, são 20
Josh, after
horas.
those final series
Thrust weight is 1.7.
following along, after those critical maneuvers,
Committed thrust still 90%.
90% thrust. We'll hear those call outs periodically. We started at full thrust, 90%, still throttling. And good performance on that engine.
That's a great call out. Two things there. Nominal performance on this
Estamos em
engine as
performance
well
boa,
as the helium tank.
né?
So
Então aí
what we
tem
haven't
descida.
mentioned so far in the show is that the helium tank pressurizes that liquid methane and liquid oxygen
Né?
tank.
Lembrando que
But
estamos
in
aí
addition, it's
utilizando
also used
os seus
for
tanques aí
reaction
de
control system. Those are the
metano e
small
oxigênio
spurts that
líquido.
you see at the top of the lander in the animation that control the vehicle's attitude. So for things like landing on the
Então
moon,
aí na
you
parte
really
então
want to land at the
de
right
descida
attitude.
final aí
That way your
controlada.
antennas are facing back direct
6
line of
minutos
sight
para o
to Earth,
pouso.
and you can get that ultimate confirmation once you do suspect that you have landed on the moon.
Agora, pelo horário de Brasília, são
Alignment is
20
an
horas
important element
e
of
18
landing on the moon,
minutos.
Josh. We're expecting the high gain antennas to
Estamos
be
então
pointed
acompanhando
towards
então
Earth
a
to
descida
confirm,
final aí
but
do
there may be a
Odisseus até a
We are
superfície da Lua.
expecting some
Lembrando que o
sort of
pouso então vai
delay. I was
acontecer
talking to the mission
lá no
directors
Polo
about
Sul.
how quickly we could receive a positive confirmation after this landing process is through, and there was some dispute over how long the earliest was just about 15 seconds after we see timing of when
Então
the
pouco a
event is
pouco, então aí
supposed to
estamos aí
happen. So
acompanhando
right now
a
we're tracking
descida
about
de sua órbita.
5:24 p.m. Central Standard Time, so maybe anywhere from 15 seconds
Então
after
quem está
that.
chegando na nossa
Maybe
transmissão,
a few
estamos
minutes, 2 to
acompanhando
3
a
minutes
descida
while we work
descida
to
então do
acquire that signal,
Odisseus.
because as you mentioned,
Já
the
estamos bem
lander is
abaixo aí dos
going to a
4
general
quilômetros.
area.
9 kilometers altitude.
9 kilometers altitude call from Tim Crane. The lander is going into a
Estamos
general
então aí a
area that
9
we say this is the
quilômetros.
general area we want you to fly
Subimos
to.
pouco.
It's using that hazard relative navigation to make better decisions about this is an area with the least amount of slope. This is an area that's free of boulders and other obstacles. So it's making autonomous decisions about where to go.
3 minutes to go. Breaking 1.
3 minutes call. Just to wrap that up, when the lander is making those decisions, Gary, it's also very difficult to track. We've been very fortunate thus far tracking communications to this point.
To wrap that up, Josh, 3 minutes, that brings us to just shy of 5:22 p.m. Central Time. We should hear that the power descent and initiation burn is complete. Then we'll begin the next series of maneuvers to get us towards vertical and terminal descent. It starts with the pitch over.
And just looking at our notes here, we did go into this
Agora então passando uma etapa então do nosso descida de órbita, né? E até o pouso. Será então aí onde vamos aí nos colocar, né, na posição vertical e para então aí fazer a sua descida, né,
So this is a throttle liquid methane, liquid oxygen engine. We lit the engine at PDI, and while we are changing into a
Que momento, hein?
vertical
Que momento de
descent and
ansiedade.
terminal descent and then landing, that is a throttle down to the lunar surface. And when we do get out of PDI, if we hear that call of PDI complete, good burn, everything after that is going to happen in very quick succession, Gary. The time it takes to go from pitch over to landing, or what we estimate landing to be, just looking at maybe 90 seconds is what we expect nominally.
3 minutes to touchdown.
There is some wiggle room. 3 minutes to touchdown call from the mission
3
director.
minutos. 3
For an on-time
minutos.
landing, that sets us a little after 5:23 p.m. Central Time.
Right, our notes going into this burn, 5:23 and 25 seconds.
The autonomous operations, Josh, sets this to a clock. This is exactly what we got relayed before the start of
Still
our coverage today.
processing.
We're right on track.
Depause terrain relative navigation measurements.
Excellent call out. That solution that flight controllers were working so hard on to make sure HRN was working, pulling on extra resources
os
that
instrumentos
weren't
então de
originally planned
navegação
for
estão
from those two laser
funcionando.
beams from NDL. It appears and sounds like that solution is working, and the
Aí
people
para
working to patch that
ver
software
aí, então, aí
were
as
certainly
soluções
under
aí
pressure.
para
The
o
clock
pouso
was
mais
ticking as we
suave, né,
went into
sistema
that
de
extra
navegação.
lunar orbit. It wasn't a situation where we could just sit in lunar orbit and try to solve our problems indefinitely, and it's sounding good so far on the
2
call.
minutos.
Remaining till touchdown.
2 minutes to touchdown. That required a patch to be designed on the ground and uplinked to Nova C to confirm that those
2
laser
minutos então aí
sensors
para o
on
pouso.
NASA's Navigation Doppler LiDAR could be routed to
Então o sistema de
the terrain
navegação aí
relative
desenvolvido
navigation
pela
and
NASA
hazard
já
relative
está
navigation.
em
That
uso
column is
nesse
Right, I do have an
momento.
altitude reading.
Standing by to see if we can get an altitude reading from FIDO here. That's Flight Dynamics Officer Sean Stewart on Blue
Estamos
Team.
aguardando então novos dados.
Confirm that looked like a pitch over gimbal.
Let's do it.
Sounds like we have some data that confirms pitch over. This starts the HDA process. That's hazard detection avoidance. Throughout this show, you've heard Gary and I
Então
talking
temos aí a
about
confirmação
the
do
problem that was attempted to
HDA,
be solved in lunar orbit,
é o
making the
radar de
decision
detecção
to not only postpone the
avançada,
show.
NDL indicates altitude of 1,000 meters.
é para a detecção então aí
1,000 meters call out
de
from
pouso aí
NDL
seguro.
that is coming from flight management. This is a system right now. NDL was not intended to be the primary landing system on this.
Então ele
Instead,
está
we're using
nesse
two
momento
laser beams
procurando
from
então aí
NDL
lugar
and
de
feeding
pouso
that
aí
into that
mais
hazard
seguro, né?
detection and
Com
avoidance system
o
that you see on your
HDA,
screen right
né?
now,
Azar
with the lander making autonomous decisions about where it wants to
detecting,
land. That is generally
Less than 1 minute remaining
landing.
to touchdown.
less than 1 minute remaining for
minuto.
touchdown.
And again, that's the time of touchdown. It may take some time to actually confirm the
Estamos
status
aí no aguardo da
And
confirmação
in
então
this
para o
process, we
pouso.
do have a deployment of Eagle Cam attempting to take the third-person images of Nova C going down to the lunar surface. We are inside of 1 minute. Gary.
Agora é o momento final, hein? Estamos aguardando a confirmação do pouso.
Yes, we're well into blowdown.
Estamos aguardando a
And we're tracking here in
confirmação.
the broadcast booth. The clock has reached the expected.
May take a minute for comms to reestablish. Stand by.
There it is, mission director beating us to it. We've reached the expected time of landing, but now is the process of waiting for comms, and we are in standby mode, as you heard it from the mission director, Dr. Tim Crane.
Estamos
And
ainda
1 minute has
aguardando.
elapsed from the notes that we have, Gary, of that original burn starting at PDI.
And you have carrier lock.
That's MD asking if we are getting the ground stations locked on to Nova C.
20 horas e 25 minutos pelo horário de Brasília. Estamos aguardando a confirmação do pouso da superfície da Lua.
That carrier lock call, Gary, we expect that to come from GroundNet or COM, that conversation possibly not happening on our public channel that we have access to. We're just standing by to hear that come through the channels as we approach almost 2 minutes since we estimated the landing time. We did get a few call outs on the side, folks coming into the room saying there was about a 2-minute forgiveness in our timetables.
We are checking our antenna reception.
Está fazendo a
Checking antenna
checagem.
reception.
Estamos aguardando a confirmação.
And we're standing by, Gary. We're standing by just as we approach 5:26 p.m. Central Standard Time. Given those mission
Estamos
directors'
aguardando
notes
então o
of the
momento da
flexibility
confirmação aí às
between what we
20
were
horas e
tracking, what we
26
were given was
minutos.
just about 5:24.
All stations, this is MD. Please look back through your logs and confirm the last information you had, and we'll determine this is a comm outage.
And that's the mission director, Gary. These are our notes here of what we believed. We talked about the comm outages with the lander making autonomous decisions. This is the process of going through the last bit of data that came into Nova Control and working to verify, okay, this is the last bit of data. Where was the lander possibly going? How do we look for it and establish those communications? Nova C uses 4 antennas placed at the top of the lander that are designed to capture these communications. But we did expect this. We talked about it, that this is a communications challenge in it of itself, and right now we're standing by to hear that communications call out.
We're just a little more than 3 minutes from the time of when the clock reads 0 for Nova C landing on the moon.
And we just checked with our team here in the broadcast booth, decided to let's stay on this. All the chatter, we are not hearing
20
on
horas
this public
28
channel,
minutos
Gary.
ainda
All
pelo
things
horário de
indicate that we are
Brasília.
working to
Estamos
solve a
aguardando
communications, a possible communications
ainda
challenge
a
in this moment, so we're going
confirmação.
to continue to stand by.
For those following along,
MD Prime on IM-1.
Go for prime.
Yeah, I guess you polled the room looking for states, and we're going to go ahead and cycle the ground transmitter on Goonhilly and do some RF sweeps. Is that your plan?
That's correct.
Roger, copy.
And that's just what we had in mind in our notes, Gary, is that if we encounter a communications challenge, we mentioned how difficult it is to land on the moon and continually have those communications. What you just heard there is folks talking about using the Goonhilly Earth Station Limited dish in the UK to do a sweep looking for that signal. We mentioned that autonomous process of the lander reassigning itself somewhere that it believes is safe. Going into it, we heard that the HRN camera was functioning and able to make those decisions after what was a 2-hour orbit of problem solving with Intuitive Machines' TRN and HRN cameras, the laser rangefinders assigned to those. Those are the ones that Intuitive Machines installed inside the navigation pods.
Pessoal, estamos aguardando ainda a confirmação, ainda temos aí o pouso ou não, né, confirmado aí com sucesso ainda ou não, 20 horas e 30 minutos.
Pointing vector with our antenna for post landing.
Yep. We spent about 2 hours in orbit to solve that problem. We got good readings on the way down. And right now, we are working to confirm communications on the surface of the moon, roughly around the Malapert A region. That is the South Pole region of the moon.
That's right. What we do know is the power descent initiation. We were following along in the status calls. We executed a pitch-over maneuver, and we're counting down the clock to a landing time at
Está demorando
5:23
bastante, né,
p.m.
para
Central
confirmação
Time.
aí,
Well, Josh described those processes of
né, do
working on the
pouso então aí
communications
ou não do
component to confirm
Odisseus.
data from the lander, pulsing the teams surrounding him to check the status of Nova C and the data that they were receiving here in Nova Control to confirm landing. And part of that, Josh, as you described, is communications. We're standing by.
Fido MD on IM-1.
QMD.
I'm looking at our phase plane there for the last part of the flight. Looks like we had excellent pitch and yaw control throughout, but I did see a little bit of a roll excursion. Could it be that we landed off angle and roll in the final phase?
So I do see we had up to an 8-degree excursion. We're about to begin the roll maneuver, which is about
terminal phase.
The terminal phase, which is a large roll maneuver to get to landing attitude. That's the last data point I have. But up until that point, we were really solid.
Right, so terminal phase begins at 30 meters. Or
pessoal, eu acho que
post-HDA.
400 meters.
Very good.
And that's a great conversation confirming.
That's good ground network, good for box scan. Make that go.
Yeah, that was good confirmation of the process that we were very familiar with, talking about the attitude of the lander, making sure that those antennas are within direct line of sight with Earth stations, ground stations on Earth, excuse me.
Mission director at all stations are also updating our pointing vector with our dishes to make sure that they're tuned in on our final landing site.
There's a call. We're searching for that communications back to the ground station. This one particularly is in the
Eu não
UK that's
quero
tracking us. And it's important to note
trazer
Gary,
mais
that we
notícias,
have
mas
an entire network dedicated to working these communications problems. It's been active this entire mission. And the largest, most powerful dish out of all of them is about a 64-meter dish in Australia. That time to search with that opportunity with the largest, most powerful dish,
talvez eu
we're
acho que
looking at
se
about
espatifou.
12 to 13 hours after our estimated touchdown. So this is a process that we could be looking and
Eu
searching
acho,
for
né?
the lander's
Não quero
signal
trazer
for
mais notícias
confirmation
não, mas
for quite some time.
se
But
até
we're going
agora
to
não
continue
houve
to listen in and
comemoração,
stand by as our flight
nós estamos
controllers are working
aguardando
with
aí,
the ground
né,
station in
desde
the United
das
Kingdom
20 horas e
to
24
work
minutos,
this issue, work this
né,
problem.
já
It's
bastante
another
tempo,
challenge,
né,
very
aguardando,
similarly to the challenge solved just
né,
to make it
o
this
pessoal
far.
já não tá com caras aí de boas.
Science of life, we have a return signal we're tracking.
Vamos ver, né? Vamos ver. Esperamos que não.
We have an onboard fault detection system for our communications that after 15 minutes with lack of communication will power cycle the radios, and then after that for another 15 minutes it will then switch antenna pairs. So we have some time here to evaluate. We do have signal that we're tracking, so we'll see what happens.
There's a great call out about the autonomous systems installed on our Nova C-class lunar lander named Odysseus. The process he's mentioning, Gary, is very similar to the one that we were preparing ourselves for at AOS, to where the lander has systems in place to recycle its antennas, to switch antenna pairs. That was very similar to what we thought we were going to need to do after acquisition of signal.
Estamos aí aguardando
When we
a
separated from the second
equalização
stage
do
of the launch
sinal.
vehicle, if we made it to a certain point, the lander was autonomously programmed to start taking matters into its own hands, and that was the information that our mission director, Dr.
We're not dead yet.
We're also not dead yet.
Estamos ainda aguardando a equalização do sinal.
And the key here, Josh, is patience. It's 5:34 p.m. Mission Director Tim Crane confirming that it could take 2 phases of 15-minute increments to confirm the status of the landing. So we could be here, and we'll stand by and monitor as Nova Controls continues to work this issue.
Yeah, tense moments inside of mission control with the most qualified folks.
We're picking up a signal from our high-gain antenna and transmitter. It's faint, but it's there. So stand by, folks. We'll see what's happening here.
All right, we're going to continue to stand by. Let's keep this camera on inside of Nova
Estamos
Control.
ainda
It sounds like we
aguardando para
are
ver se ainda
getting
temos
some
aí a
kind of faint
I want to
confirmação.
send a series of commands to reactivate, make sure we're transmitting to keep Aquasonics active.
Momentos aí então de angústia. Aí já sabemos então aí se houve ou não pouso. que já passou aí mais
We're
de
still standing by the last call from
12
Mission
minutos,
Director
né,
Dr.
depois do
Tim
pouso,
Crane,
né,
said
aí
we're getting a
provável
faint
tempo do
signal
pouso,
from Odysseus's
né, na
high gain
superfície da Lua,
antenna.
e aí até agora não houve confirmação. Estamos aguardando a equalização do sinal.
All stations, this is Mission Director on IM-1. We're evaluating how we can refine that signal and dial in the pointing for our dishes. What we can confirm, without a doubt, is our equipment is on the surface of the moon, and we are transmitting. So, congratulations, IM team. We'll see how much more we can get from that.
An excellent call from our mission director,
MD
Dr.
Prime
Tim
on
Crane.
IM-1.
And over
Go
to
for
our
Prime.
CEO, Steve Altemus.
Yeah, if I could just pass on a few words to the entire team.
E aí
and,
temos então a
Intuitive
confirmação
Machines
de
and
que
Superbad
houve
here
então
in
o
the-
pouso.
Here in the mission control. What an outstanding effort. I know this was a nail biter, but we are on the surface. And we
E aí
are
temos o
transmitting.
pouso confirmado na superfície da Lua.
Houston, Odysseus has found his new home.
An excellent call, and this
Então,
is our
Odysseus
team
está
of
na
intuitive
superfície
machines
da Lua.
mechanics and their families, their friends, everyone who has sacrificed so
Getting those
much
updated
to
pointing
make it
files to
this
our
far.
stations.
Odysseus então confirmando aí, então Odysseus está nesse momento na superfície da Lua. Houve então aí um pouso confirmado.
Gary, that was something else, a faint signal. Now it's time to work on refining that signal. But Dr. Tim Crane, our mission director today, making the call. Odysseus has a new home.
It shows the disciplines of the flight controllers
Então,
in Nova Control.
Odysseus está em sua
They
nova
waited
casa.
until there was absolute confirmation that there was a signal, and then that was when they took the moment to celebrate. We saw that it wasn't just the individuals in Nova Control that contributed to the mission.
Grande
The
momento.
contributions to enable the success
Então
of
Odysseus
Nova Seas landing on the
está
moon
em
stretches
sua
far
casa,
and wide.
neste momento,
We
sua
showed,
nova
of course,
casa,
some of
nesse
the folks
momento na
watching there, but
superfície
really it extends even
do Polo
farther
Sul
than
da
this.
Lua.
A wonderful and truly amazing moment to celebrate. The U.S. has landed on the moon once again.
And to everyone, you mentioned it goes beyond just
Grande
the folks
momento
that we
aí,
saw
esse
on
momento
camera waiting
histórico.
and working through those tense moments, but
É,
their
após
friends,
52
their families,
anos,
and everything it took to get
voltamos
to this
então aí à
point.
superfície
We're still
da
expecting an
Lua.
image. We expect that to come down sometime in
É,
the
estamos
future,
então aguardando
especially
então
as
as
we look
imagens
towards some
que
high
irão a vir,
resolution
né, aí
images.
então da
Let's go
superfície da
ahead
Lua.
and it sounds like we do have a message we'd like to cut to. Can we have that message special for our folks, our employees, and folks
Estamos
watching
então
at
na
home?
superfície da Lua.
Nova
Pousou
Sea
com
landing in
sucesso.
Malapert A. Congratulations, like you said, Josh, are flooding into the teams that made this happen. Really sets a tone
Então
for
conseguimos.
the American leadership and the future of a strong lunar economy. So here's NASA Administrator Bill Nelson.
Então conseguimos.
On the 8th day of a 250,000-mile voyage, a voyage along the Great Cosmic Bridge from the launch pad at the Kennedy
Aí nosso
Space Center
administrador da NASA,
to
Bill
the target
Nelson,
of the south pole of the moon.
falando aí que 8 dias, né?
commercial
8
lander
dias de
named
viagem,
Odysseus,
aí desde o
powered
lançamento,
by a company called
aí
Intuitive
na
Machines,
no
launched
Centro Espacial
upon a
Kennedy, no dia
SpaceX
15
rocket,
até este momento de hoje,
carrying a
22
bounty of
de fevereiro,
NASA
né? 8
scientific
dias viajando
instruments
entre a Terra
and bearing
e a
the
Lua.
dream of a
Então
new
conseguimos
adventure,
aí então retornar à
a new
superfície
adventure in science,
da Lua.
innovation, and American
O pouso então
leadership in
realizado
space.
com sucesso.
Well, all of that aced the landing of a lifetime. Today, for the first
Marcando
time
então aí
in
um
more than
novo
a half
passo então
century,
para a
the
exploração lunar
U.S.
e
has
planetária.
returned to the moon. Today, for the first time in the history of humanity, the U.S. has returned to the moon. Today, for the first time in the history of humanity, the U.S. has returned to the moon. Today, for the first time in the history of humanity, the U.S. has returned to the moon. Today, for the first time in the history of humanity, the U.S. has returned to the moon. Today, for the first time in the history of humanity, the U.S. has returned to the moon. Today, for the first time in the history of humanity, the U.S. has returned to the moon. Today, for the first time in the history of humanity, the U.S. has returned to the moon. Today, for the first time in the history of humanity, the U.S. has returned to the moon. Today, for the first time in the history of humanity, the U.S. has returned to the moon. Today, for the first time in the history of humanity, the U.S. has returned to the moon. Today, for the first time in the history of humanity, the U.S. has returned to the moon. Today, for the first a commercial company, an American company, launched and led
Então, pela
the
primeira vez, uma
voyage
empresa
up there.
privada, comercial
And
aí,
today
privada,
is a day that shows the power and promise of
CLPS,
NASA's
junto com a
commercial
NASA,
partnerships.
aí a começo Lunar Payload
Congratulations to
Services,
everyone involved in
então
this
aí
great and
levando
daring quest at
junto
Intuitive
com
Machines,
a
SpaceX, and right here
Machine,
at NASA.
o
What a
Odysseus
triumph! Odysseus
para a
has
superfície da Lua.
taken the moon. This feat is a giant leap forward for all of humanity. Stay tuned.
All right, thank you, Administrator Nelson. Again, Nova C and the United States has landed on the moon at 5:23
Novamente, os
p.m.
Estados
Central
Unidos
Time
está
today,
de volta então à
February
superfície da
22nd,
Lua.
2024. Congratulations to Intuitive Machines on the successful landing. Science and data gathering is already underway and will continue for roughly 7 days on the lunar surface, activating payloads
Então estamos aqui também encerrando aqui a nossa transmissão de hoje, lembrando que logo mais teremos missão Starlink. A missão Starlink logo mais a partir das 1 da manhã no nosso canal WillPTV.
Thanks to NASA for the continued support to enable today's successful landing, and of course
Nesse momento
everyone
histórico,
at Intuitive
né,
Machines,
aqui
their friends
com
and family
sucesso
who
então aí
made
do
all of
Pouso
this possible.
na
That will wrap
superfície
up
da
our
Lua,
coverage of Intuitive Machines'
realizada,
IM-1
missão
mission.
realizada com
Thanks for joining
sucesso.
us.
Vamos aí então aguardar as imagens logo depois aí para vocês. Então estamos encerrando aqui a nossa transmissão, né? Quero agradecer então a todos pela audiência, pela paciência, e nos vemos então mais tarde aí pela missão Starlink número 140 do grupo 715. Então por hora é só, pessoal. Nos vemos daqui a pouquinho. Obrigado pelas inscrições, pela audiência e pelos likes. E histórico, né? Missão histórica aí. História ao vivo, né? Fazendo história ao vivo. Muito obrigado e nos vemos até lá.